Hello everyone, welcome to my channel. So today we will learn about how to calculate the critical voltages VOH, VOL, VIH and VIL of a resistive load and MOS inverter. So today we will study about a resistive load and MOS inverter. So what does it mean? That we are taking this NMOS enhancement type transistor as driver circuit, and in the load we have connected a simple resistor RL across which VR is measured, and ID will be equal to IR, and what will be the output voltage? It will be equal to VDS. And at input of the driver transistor we apply VGS, and VSB is taken as 0, so threshold voltage VT is equal to VTO. And this is the simple or a typical voltage transfer characteristic curve, and which we have taken y-axis as V out and x-axis as V in. And you can see that here are the critical voltages. This is VOH is which is equal to VDD. We will calculate that. And at VIL slope is -1. At VIH slope is also -1. And VOL, here it is the lowest output voltage when input is very high, which is equal to VDD. So let us start our calculation. So we know that this is an enhancement type NMOS transistor. So because this is the symbol here and arrow is going inwards, so this is an NMOS enhancement type transistor, and it has a positive threshold voltage. And suppose in the starting input is very low and input is less than threshold voltage of the transistor, then we can say that transistor will be in cutoff region because transistor will not be on, so there will be no drain current conducted here. And because ID is equal to 0, so we can say that IR is equal to ID is equal to 0. And if this current is 0, then what happens? Then there will be no drop here, and this term will be 0. So all the output, all the voltage is actually here. So VDS will be equal to VDD, or you can say V out will be equal to VDD. So we can almost say that when input is 0, VOH is equal to VDD. So this is our first calculation in which we have calculated VOH. So when input is very less, or you can say it is less than threshold voltage of the transistor, then the driver transistor will be in cutoff, and therefore no drain current will flow, and VOH will be equal to VDD. So this is our first calculation. Now we will further calculate VOL. So first of all, it is important to know what is VOL. So VOL is obtained in the VTC curve when our input is very high. So you can see here the VTC curve. When input is very high, when it is equal to VDD, then we can obtain this VOL. It is known as output low voltage when V input is equal to VOH, or V input is equal to VDD. So suppose if input is very high, then you can say that drain current is also very high, because as you increase VGS, here drain current will also be very high. And if it is very high, then output will also be because drop will also be large, so output will be very less. So you can say that the driver will be in linear region. Okay, so for this, the NMOS enhancement transistor will work in linear region. And why this formula IR is equal to ID, we can put the value of IR as VDD minus V out by RL. And what will be this equal to? So it will be equal to ID, and this will be in linear region. So it will be like VDD minus V out by RL, Kn by 2 times VGS minus VTO, VDS minus VDS whole square. And we know that V output is VOL, and in place of VDS we can simply write VOL. Okay, and in place of VGS, which is V input, okay, So VGS is V in, and V in this case of calculation of VOL is should be equal to highest voltage, that is VDD. So we can write simply, we can put the value of V input as VDD, V output as VOL in this equation number 3 here. Okay, and simply rewrite this equation as VDD minus VOL by RL, which will be equal to Kn by 2 times VDD minus VTO VOL minus VOL whole square. Okay, now this 2 will be moved inside. Okay, and Kn is also moved inside. Now this formula will be like this. Okay, by taking the LCM here and here, and if we take 2 here, it will be 2 VDD minus 2 VOL 2 KNRL VDD minus VTO VOL minus KNRL VOL whole square. If we divide the whole equation 5 by KNRL, it will be like this. 2 VDD by KNRL minus 2 VOL by KNRL is equal to 2 VDD minus VTO VOL minus VOL whole square. And by simple rearranging of equation, we can get this. VOL square minus 2 VDD minus VTO VOL minus 2 VOL by KNRL plus 2 VDD by KNRL is equal to 0. By taking VOL common, we get this equation number 6. And what is the solution of this quadratic equation? Okay, remember one thing, there will be two solutions, but we take the negative one because VOL should be considered very low. Okay, so we take this, we put this from the solution of quadratic equation, and it will be b square minus 4ac. So we write this, but we take the negative part here, and VOL will be simply equal to VDD minus VTO plus 1 by KNRL under root of VDD minus VTO plus 1 by KNRL whole square minus 2 VDD by KNRL. Now we will calculate the calculation of, we do the calculation of VIL, and VIL is the input low voltage at which the output is just high, it is just equal to VDD. So it is at the transition, near the transition curve. So here slope is equal to -1, and what it does, it means that dV out by dV in should be equal to -1. And what happens to the driver circuit here? So still the output is very large, and output is very large, it means the driver should be in saturation. So because output will be very greater and there will be less drop, so that means the driver must be in saturation. So in that case, IR will be equal to ID sat, and IR we know this value, we have already written this VDD minus V out by RL, and it will be equal to Kn by 2 V in minus VTO whole square. And if we differentiate both sides by V in, what we get of this equation number 7? Okay, so we get like something like this, -1 by RL dV out by dV in is equal to Kn by 2 times V input minus VTO, and by putting the value dV out by dV in is equal to -1, and by putting the value VIN is equal to VIL, we can get the VIL in terms of, by simple rearranging the equation as VTO plus 1 by KNRL. Now how to calculate VIH? So first of all, we again move to VTC curve. So in this curve, we can see that VIH is the input high voltage at which the output is very low. It is just equal to VOL, very low voltage. Okay, so when output is very low, the driver should be in linear because there is more drain current, and at that point VDS is less than VGS. So VGS minus VTO. So whenever V output is very less, the driver is in linear. So IR will be equal to ID, but now the drain current will be in linear region, and then we can calculate the value of VIH. So here again IR will be equal to VDD minus V out by RL, and it will be equal to Kn by 2 times V input minus VTO V out minus V out whole square. And when we differentiate this equation number 8 with respect to V in on both sides, then we get -1 by RL dV out by dV in. Okay, and here we perform a product rule because there are two terms, so there will be 2 input, 2 is taken as common, so V input minus VTU dV out by dV in, plus when we take V out as constant, it will be given as 2 minus 2 V out dV out by dV in, and just put the value of dV out by dV in minus 1 in whole equation. Then you will get something like this. It will be plus 1 by RL, Kn by 2, 2 in the place of VIN we put VIH, and there is minus 1 plus 2 V out, and here it also plus 2 V out. So what you will get, that you will get 1 by Kn RL is equal to 2 V out plus VTO minus VIH. So the equation of VIH is equal to VTO plus 2 V out minus 1 by KNRL. But still, this V out, you don't know how, this is one of the unknown parameter. And we simply want something in terms of MOSFET parameters. So what we can do? We can do one thing. We can put this value of V in our equation number 8. This equation. Okay. And when we put this equation, we can get here. Okay, so here you write V in as this equation, VTO plus 2 V out minus 1 by KNRL, and then we will solve it. And when you solve it, you will get that V out is coming to be root 2 by 3 VDD KNRL. Okay, and if you put it this equation VIH, okay, here, then you will get VIH in terms of known parameters, not in terms of V out. So here, as you can see, VIH is equal to, or VIN or is equal to VTO plus 2 times root 2 by 3 VDD KN RL minus 1 by KN RL. And if you take 2 inside, then you will get VTO plus root 8 by 3 VDD KNRL minus 1 by KNRL. So if you like this video, please like, share and subscribe my channel. Thank you.